part 2 of the Unit 1 Finding Limits 1 worksheet notes. So we have a function over here on the right, and we've got numerous limits that we want to be looking at. So the first limit that we're looking at is what happens with this function when we approach the value of 4. So here's my value of 4. What's going on with this function as we approach 4? The little plus sign up here is telling us that we are approaching the value of 4 coming from the right hand side. And we can see as we're coming from the right hand side, we are approaching a value. The function is going to have a value of 3. If we're coming from the left hand side, which is what the little negative denotes, then again the function is approaching 3. And then if we have no positive or negative afterwards, we're asking what's the value of the function when x approaches 4, regardless of whether we come at it from the right or we come at it from the left. And we're coming, whether we're from the right or from the left, we're coming to the same exact value of the function, which is 3. This question, which you've seen numerous times in previous courses, is just simply asking what is the value of the function at 4, and the value of the function at 4 is 3. So pretty straightforward limit here. The limit is exactly what the value of the function is. Now at what this is asking, instead of the value, we're looking for the derivative. So what's the slope? What's the slope here? And we're looking for the slope here at this exact point. You'll notice this is at the function at this point is a line right through here. So the slope is just simply found by finding the rise over the run, which is 1/2. Right? So let's erase this and look at the next series of limits here. So the next one here, we're looking at what's going on with this function at 2, and we're going to start by looking at it coming from the right hand side. So we're looking at what's going on here at 2. We're coming in from the right hand side like this, and we are approaching a value of 2. As we come at it from the left hand side, little negative back here, walking in along the function, and it is approaching, the function is approaching 1. So now when we look at the limit as x approaches 2, regardless of whether we're coming from the right or the left, we have a conflict here. It's either going to be 2 if we come from the right, or it's 1 if we're coming from the left. There is not one single answer, one single number. So the way we notate this is DNE, which stands for does not exist. And the reason that the limit does not exist is we have a mismatch. The left limit and the right limit do not match. Now, the function itself, even though we don't have a limit, the function does indeed have a value, and that's right here. So the value of the function at 2 is 1. Right? Next set of limits. We're going to look now at what's going on at -6. Right? So right here. And as we come at -6 from the right hand side, we come this way. You see we are approaching a value of 3. As we come at it from the left hand side, we are approaching a value of 3. The limit of the function as x approaches -6, well, the left limit and the right limit match, so then the limit at -6 is 3. But the value of the function at -6 is not 3. The value of the function at -6 is down here, and it is -1. All right, a couple more. Let's look at what's going on at negative 1. Oops. Let me erase this. So at negative 1, you can see that the function is asymptotic. And as we're approaching negative 1 from the right-hand side, the function is headed up this way, and it's headed off to infinity. So one could say that the limit of this function is approaching infinity, but the limit question is actually asking for a value. Give me a number. There is no number. There's a concept. The concept is infinity. So some people actually write infinity, but really the limit does not exist because infinity is not a number. It's a concept. Same thing is happening on the left side. As this function on the left side is approaching negative 1, it's headed off to infinity. So once again, the limit of this function at negative 1 as we're approaching from the left side does not exist. And the reason it doesn't exist is because it's infinity. So put parentheses around this. So you notice up here that does not exist is because we have a mismatch. Down here that does not exist is because it's approaching infinity. The left and the right, again, they match, if you will, but they match because they do not exist. And it's approaching infinity from both sides. And the value of negative 1, the value of the function at negative 1, again, same concept, does not exist. I cannot give you a value. I can merely give you the concept. And the concept is infinity. Last one. So we'll erase this. So the last limit here is we're looking for what's going on when we approach negative 2. Now, let's see, we'll pick a different color. Let's go with blue. So as we approach from the right-hand side, we're coming down, and you'll notice that we are approaching, as we come from the right side, the value of the function is approaching 1. As we come from the left-hand side, the value of the function is approaching 1 again. The limit of the function as we approach negative 2, regardless of whether we come from the left or the right, because the left limit and the right limit match up, it is 1. The value of the function at negative 2, there is a value, it's right there. It is 1. And then this last one we need to take a little bit of time to think about. So what I need to do is I need to find the slope of this function at this point. So I need to draw the tangent. Now the problem here is that when I try and draw the tangent, I don't quite know how to draw the tangent. I could draw the tangent going like that. I could draw the tangent going like that. I could draw the tangent going like that. It's not quite clear which one really should be the tangent. And because I cannot decide what the tangent is at that point, I can't find the slope of the tangent, and if I can't find the slope of the tangent, I cannot find the derivative of the function at that point. So we write here, oops, wrong color, because we're looking at the value at negative 2. I write here that the derivative of the function at negative 2 does not exist. All right. Now, I would like you to see whether or not you on your own can do example 2. You should be finishing example 2 for the notes, and when I check off your notes in class, I will be checking off to make sure that you have done all of example 2. All right, so you're going to sketch some sort of graph here that meets these conditions, right? At the point 5, at 5 down here, the limit of the function has got to be 6. And the value of the, 5 isn't over here, 5 is over here. Excuse me. There we go. So at 5, which is over here, we need the value of the limit to be 6, and the value of the function does not exist, which implies that there's a hole. Okay, so again, finish this for your notes to bring into class so that I can check them off. And we're done with these notes.